This video is going to be about rational functions, and you should have watched a couple of videos before this, and that is how to find the intercepts, how to find the asymptotes, and how to find the domain. I'm going to combine all that together in this video, and let us get started. So here's the first problem. This is a rational function. The first thing that I'm going to do is I am going to find the domain. If you watch the video on finding the domain, if you have a fraction set up like this, if you just set your denominator equal to 0, then you'll find what the domain is going to be. So I'm going to take my denominator, which is x plus 10, set it equal to 0, and then I'm going to solve for the x value, and that's going to give me negative 10. So when you find the value from the denominator, that's the value that doesn't work. So however many you find, those are all the values that can't work. So if I wrote the domain, it's going to be negative infinity up to negative 10 union with negative 10 to infinity. Because basically you're saying every number on the number line works except for negative 10. So this is my domain. The next thing I'm going to find is the intercepts. If you watched the previous video, there are two types of intercepts. That is your x-intercept, and you also have your y-intercept. I'm going to start out with finding the x-intercept by setting the y equal to 0. That's how you find the intercept. So I'm going to set the y value, which is basically like your f of x. I'm going to set it equal to 0. And if you watched the previous video when we were trying to find the intercepts, and if you had a fraction set up like this, you had to multiply both sides by the LCD. So that's going to be my next move. I got to get rid of the fraction. So in order to get rid of the fraction, I'm going to multiply by the LCD. Boom, boom. And if you multiply this side by the LCD, you just get 0 anyway. So this will be 0 is equal to 2x. That's what I have left in the numerator. And so to solve for x, I'm going to divide both sides by 2. And you end up just getting 0 divided by 2 is just 0. So you get x is equal to 0. So that's one of your intercepts. Let's go over to your y-intercept. And to find the y-intercept, you set all the x's equal to 0. So if you look at the original problem, f of x, which is y, equals 2 times 0 over 0 plus 10. Okay. So let's simplify the top, simplify the bottom. 2 times 0 is 0. 0 plus 10 is 10. And what's 0 divided by 10? That's going to be 0 as well. So your x and y intercept, they're both at 0, 0. Okay. If you get 0 for the x, you're going to get 0 for the y. Just FYI on that. So we found the intercepts. Now, next in line, I want to find the asymptotes. So we're going to go through each one of the asymptotes and see if we can find them. First, I want to start out by finding the vertical asymptote. So if you watch the previous video, in order to find the vertical asymptote, you need to first try to reduce the original problem. And if you look at the original problem, it said this: 2x over x plus 10. When I look at this problem, there is nothing I can do to reduce it. And in order to reduce, you have to factor the top, factor the bottom, and see if there's anything that looks the same on the top and bottom. In this case, I don't have anything to reduce, so I can go on to the next step. The next step says set your denominator equal to 0. So I take the x plus 10, I equal it to 0, and then just how I did with the domain, I get x is equal to negative 10. So this is my vertical asymptote. So remember, our vertical asymptote is a vertical line, so it's going to be x equals something. So x equals negative 10 is your vertical asymptote. You see how this is different than your domain. Your domain is x is not equal to negative 10. So that's a big difference, okay? So vertical asymptote is x is equal to negative 10. Now I'm going to find the horizontal and oblique. Horizontal or oblique. Okay. And I put these two together because the procedure is kind of the same for both. So horizontal and oblique have to do with whether the rational function is proper or improper. So when I look at the original rational function, okay, I need to see if this is a proper or improper rational function. So the way that I do that is I look at the degree of the top and I look at the degree of the bottom. So if you look at the top has a degree of 1 because the highest exponent is 1. If I look at the bottom has a degree of 1 as well because the highest exponent is 1. So if you think about the fraction 1 over 1, this right here is actually an improper fraction. It's an improper fraction, but just a shortcut here, if the numbers are the same on the top and bottom, the way that you find the asymptote is just take the coefficients in front of each one of the numerator and the denominator. So because this is an improper fraction and the degree is actually the same on the top and bottom, all you have to do is take the number sitting in front at the top and then take the number sitting in the front on the bottom. Okay, so what you have here is a horizontal asymptote at 2, which is the number in the front at the top. And then at the bottom, you can't see it, but it's a 1, right? The number in front on the bottom is going to be a 1. So y equals 2 over 1, which is the same thing as saying 2. So y is equal to 2. This is a horizontal asymptote at y equals 2. So if the degree is the same at the top and bottom, all you have to do is take the number sitting in the front on the top and at the bottom. That's how you find your asymptote. And it will be a horizontal asymptote. So just for the sake of my math lab, they're going to ask you for the vertical asymptote. That's one question. You will put x is equal to negative 10. They're going to ask you for the horizontal asymptote. You would say, okay, y is equal to 2. That would be your horizontal asymptote. Then they're going to ask you for the oblique. This does not have an oblique asymptote because it has a horizontal. Okay, so when you get to the question that says, okay, what are the oblique asymptotes? You're going to click the button that says none. Okay, just making sure, just want to throw that out there. Okay, let's do another problem. And actually, before I move on to another problem, let me draw this real quick because there will be a couple of questions where you want to kind of look at how this would look on a graph. So I found all this stuff, right? I'm going to just a rough sketch, right? You can see how this looks in a graphing calculator, but I'm going to do this without looking at my calculator for a second. So you have a vertical asymptote at negative 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Negative 10. You have a vertical asymptote. Okay, a vertical asymptote at negative 10. And then we have a horizontal asymptote at 2. And notice if you watch the previous video on asymptotes, asymptotes aren't really lines. They're just like imaginary lines that the graph gets extremely close to. So that's why I made these lines dotted. Okay, another thing that we know is that we have a intercept at 0 and 0, 0. So I'm gonna put a dot right here because I know for sure that my graph is gonna go through at 0, 0. Now, based on what I see on this graph, because I know my graph can't go, it's gonna go through this point here. So it's probably gonna do something that does something like this. And the other part is probably going to be up here in this little corner right here. Because an asymptote is kind of like a magnet. It kind of sucks the graph towards it, but it's not necessarily going to touch. And there's no other way I can think to graph this. I couldn't graph in this area right here because I only have an intercept at 0, 0, right? I can't graph up here because I do have that intercept at 0, 0. So I know for sure I need to be in this area where the intercept is. And then I knew that the second part of this graph was going to be up here in this upper area just because there's no other intercepts. Okay. Now, if you go to your graphing calculator and put the original problem in there and press the graph button, it should look just like this. Okay. So I'm going to move on to the next problem. Okay. Let's try this again. Okay. You may hear some kids in the background, but you know, it's all good. So I can already tell by looking at this problem that we have some factoring going on. So first, let's start out with the domain. To find the domain, if you watch the video on domain, all you have to do is set your denominator equal to 0. Okay. Now, in order to solve for x, you're going to have to factor here. You have to dig out your factoring techniques. So this is going to require the AC method. So I'm going to go through the AC method real quick, where you take the first number times the last number. That's going to give you negative 30. And we're trying to find a number that when you multiply, you get negative 30, but when you add, you get negative 7. That is going to be negative 10 and positive 3. Okay, so it's negative 10 and positive 3. So negative 10 and positive 3, I use those two numbers to split up the middle part of this question. Okay, now we can do factor by grouping. And let's take out this common factor. If you don't know how to do this, please watch the video on factoring. Like, factoring in college algebra needs to be like second nature. 2 and x is equal to, this one will be negative 3 over 5. So after we do that, remember these are two numbers that are not going to work. So after all that work, remember you're finding values that don't work. So I am going to write this in interval notation. So every number on the number line is okay except for these two numbers. So I go from negative infinity to negative 3 over 5. negative 3 over 5 to 2, and then 2 to infinity. This is your domain. Okay. Intercepts. Let's find the intercepts on this problem. Yep, that's fine. So let's find the intercepts on this problem. We're just trying to make sure I put everything on there right. So on the intercepts, you have x and y. So let's start with our x-intercept, which means you have to set your y equal to 0. So this will be 0 is equal to, let's see what we have at the top, 3x squared minus 5x minus 2 over 5x squared minus 7x minus 6. So we're trying to find the intercepts with this problem. Now you have a fraction. Remember what we did with the fraction. If you have a fraction, you multiply by the LCD to get rid of the fraction. So that's 5x squared minus 7x minus 6. Boom, those go away. So you get 0 is equal to 3x squared minus 5x minus 2. You multiply by the LCD, the denominator will cancel out. The more you do this, the more you're going to realize all you're doing is just slashing out the denominator and setting the top equal to 0. It's the same routine every time. So now I have to solve for x, which means I have to go through and factor again, do the AC method. So we'll do that. Got to multiply a times c. So that's negative 6. And you can do trial and error if you want to with this too. Trial and error works as well. So this is 3x squared minus 6x plus x minus 2. Then you have to do factor by grouping. That's going to be 3x, x minus 2. And then this one you can't take out anything, so it's still x minus 2. You know you're going in the right direction because the parentheses look the same. And I'm going quickly through the AC method because this video is not about the AC method. This video is about rational functions. If you need to see a video on how to do the AC method, that will be in the description box. You go and watch the video on how to factor. But I'm trying not to spend too much time with the details on the AC method. So I set each one of these equal to 0. I get x is equal to 2. And then this one will be x is equal to negative 1/3. So these are your two x-intercepts. So you have to stop and think for a second because remember we had our domain. Domain said x can't be equal to 2 and x can't be equal to negative 3 over 5. So if you go down here, you found two intercepts. One of those intercepts was 2 and the other one was negative 1/3. The 2 needs to be eliminated because your domain said x should never be equal to 2. So you need to take the 2 out of the picture. So your actual only x-intercept is going to be x is equal to negative 1/3. Okay. Now let us find the y-intercept. Y-intercept is where you set x equal to 0. And so this will be the y, and everywhere that I see x, I'm going to set it equal to 0. Everywhere that I see x, you're going to set it equal to 0. So what happens here? If I simplify the top and simplify the bottom, this is going to go to 0. This is going to go to 0. All I have left at the top is negative 2. At the bottom, this is going to go to 0. This is going to go to 0. At the bottom, all I have left is negative 6. And then if I reduce this, this is going to be -2 divided by -6, which makes it 1/3. So y is equal to 1/3. So this is our y-intercept, and -1/3 is our x-intercept. So we have our x and y-intercept. Okay, 3. Step 3. I got to find the vertical asymptote. Vertical asymptote. So to find the vertical asymptote, you need to 1, reduce it, and then set your denominator equal to 0. On this particular problem, so the original problem, look, I keep forgetting the numbers for the original problem. Here we go. So here are the original numbers for the problem, right? To find a vertical asymptote, which is in the video about asymptotes, you got to reduce and then set the denominator equal to 0. In order to reduce this, I have to factor the top. So we already factored the top. We factored the top when we were finding the intercepts. Because remember, it said you have x minus 2. And then this one was 3x plus 1. Okay, I'm looking right here. We did it right here. Okay, this is where I got that from. And then the bottom, we actually factored the bottom when we did the domain. So we actually have the factored part for, where do we do the domain? Right here. Look, right here. We have it factored right here. So I'm going to put that at the bottom. So you don't have to refactor it. If you do, you can refactor it if you want to, but you don't have to. And what was this? 5x plus 3. Okay. Now, if you see anything that looks the same on the top and bottom, you got to cross them out. And when you factor the top and factor the bottom, that's exactly what you see. You see something that looks the same on the top and bottom, so you cross those out. Once you cross those out, you set your denominator equal to 0. And now I solve for x. I get x is equal to -3/5. This is the vertical asymptote. So it's a dotted vertical line at -3/5. Vertical asymptote. Okay. 4. Horizontal and oblique. Horizontal, oblique. So the degree of the top and the bottom, that's how you know what to do here. So the degree of the top and bottom, let's look at the original problem again. Let's look at the original problem. So what's the degree of the top? The degree of the top is going to be 2, because that's the highest power that you see. The degree on the bottom. The degree on the bottom is also going to be 2. So 2/2 is improper. Okay, this is an improper fraction, 2/2. So because they are the same number, what I can do is just take the number in the front of the numerator and take the number in the front of the denominator, and that's going to be our horizontal asymptote, 3/5. This is a horizontal asymptote. And since we found a horizontal asymptote, do I have an oblique? No, no oblique. Okay. Now I want to do a couple more problems where I'm just finding the asymptotes, because I want to show you the variety real quick. So I saw this problem in my homework, so I know it's in your homework. Okay, so this problem right here, I'm just going to find the vertical, I'm just going to find all the different types of asymptotes, right? So if I want to find the vertical asymptote, I need to reduce this and then set my denominator equal to 0. Now, if I did that, let me show you what this looks like. I have to factor the top to see if there's anything that cancels out at the top and bottom. And this is a trinomial. This is not a trinomial, but it's a third degree polynomial at the top. This is the difference of cubes. So there's a formula to do difference of cubes, which is in the description box. I'm not going to go through the details of how I got this answer because you can find this in the video talking about factoring. And then at the bottom, when I factor, I get x plus 5, x minus 4. And again, the factoring details, you have to watch the factoring videos to know how to do that. So I do see something that looks the same at the top and bottom. Those two, they're going to go away. So what do? Once I reduce it as much as I can, what I do is I set my denominator equal to 0. And if I do that, my vertical asymptote is going to be x is equal to -5. This is my vertical asymptote. Okay, let's talk about horizontal and oblique. Horizontal, oblique. So the original problem looked like this. Okay, this is the original problem. So now when we reduced it, or let's just look at the degree. So the degree at the top is 3 because the highest power that you see at the top is 3. So the degree at the top is 3. The degree at the bottom is going to be 2. So this right here is an improper fraction, and it is not the same. It's not the same. It's not the same number. So what you would do if you have an improper fraction and the numbers are not the same, you have to do some type of division. So you have to do either long division or synthetic division to solve this problem. What I'm going to do is I'm going to look at the reduced form of this problem, which is going to be x plus 4 minus 16. I'm going to reduce this because this is going to help me just use the synthetic division. Instead of doing the long division, I'm going to use the synthetic division. So if I reduce it, I get this right here, right? And because this is an improper and the numbers are not the same on the top and bottom, I got to do division. So if you want to know how to do synthetic division, again, I'll put that in the description box. You have to have a lot of background to do this stuff. So synthetic division, I put -5 on the outside and then my numbers go inside. You should have just learned about synthetic division last week, so hopefully this is fresh in your mind. I bring down a 1 and then -5 times 1, boom. This is going to be -1. This is going to be 5. And then this will be -11. I don't care too much about the remainder, but I do care about these two numbers right here. So my polynomial went down 1 degree. So this is going to be 1x minus 1. So this right here is my oblique asymptote. It's going to be y is equal to x minus 1. So whatever you get when you do your synthetic division, that polynomial that you get when you do your synthetic division, that's going to be your oblique asymptote. So this right here is considered to be oblique. Because we found an oblique asymptote, there is no horizontal asymptote. Okay, keep that in mind. There's no horizontal if there's an oblique. So that is that. Let me do one more. And this one's going to be an easy one. I'll make this one simple. Because I know you're probably tired of hearing my voice. Let's do one more problem. And let's make this one kind of simple. How about this? That's simple enough. Okay. So let's start out by finding our vertical asymptote. So the vertical asymptote, I reduce it. On this problem, I can't reduce. There's nothing that looks the same on the top and bottom. Even if I factor the bottom, which would be x, what would be -7 and x -1. Even when I factor the bottom, it doesn't cross out with anything at the top. So this is already reduced. But what do you do after you reduce it? After you reduce it, you set the denominator equal to 0. So if I set my denominator equal to 0, I get x is equal to +7 and x is equal to +1. This particular problem has 2 vertical asymptotes, which is possible. So you reduce it, then set the denominator equal to 0. Those are your vertical asymptotes. Horizontal and oblique. Horizontal and oblique. So you look at the original problem. You look at the original problem, and then you find the degree of the top and bottom. So the degree of the top is going to be 1. The degree at the bottom is going to be 2. This is a improper note. It's going to be proper. This is considered to be a proper fraction because the top is smaller than the bottom. Now, when you have a proper fraction where the top is smaller than the bottom, there's no work you have to do. All you have to do is say y is equal to 0. No work. So when you have a proper fraction where the top degree is smaller than the bottom, then all you have to do is say y is equal to 0. Again, this is something that we talk about in the video about asymptotes. I hope you learned something from this. Again, as I said before, you have to have a lot of background knowledge to do this stuff right here. And if you don't have that, I have all the videos you need in the description box. See you in the next video.